Okay, so we're here with Steve Dunnington of Moog Music. Steve, longtime engineer, with the sort of just the new thing, the Spectravox that you guys are building here at Moogfest 2019. So tell us a little about what it does and just maybe walk us through some of the features.
Sure. So Spectravox is an all-analog synthesizer. It has a bank of 10 filters. They're voltage controlled. You have a resonance control for them. And then it has a front end that can do vocoding, or something like vocoding. So it's sort of an extended vocoder. It's kind of a tweak on the topology of a vocoder. So let's see. So some synthesis capabilities we have built in. I've got a VCO, and this VCO and a noise source. You can mix them together. And they're going to be applied to the 10 filters. Here, we'll do. We can sweep the spectrum of the filters up and down. It makes a very nice filter bank, and you can add modulation. Modulation flow goes into the audio rate. Side bands of spectral modulation. Okay, so that's the basic stuff of synthesis. So
you've got 10 bands there.
Yeah. So the 10 bands. The bottom one is low pass. The top one is high pass. And the in-between ones are band pass. And one of the cool things, they're resonant. They don't self-oscillate, but they're resonant. So if you hit them with a transient, they kind of ring out. So you can make some kind of percussion-y sort of sounds with them, which is a nice little bonus to have in this thing. So, so that's kind of the synthesis side of it. It's, you know, you can plug in a signal that bypasses the VCO. That's the carrier input, and that's all with this switch in vocode off. All right, so we're just using this basically as a synthesizer or a filter bank. It also has this thing that says program input. We've got a mic plugged in. You have a 1/4 inch input and also a 3.5 millimeter input for this, so you can have a variety of ways that you can get signal into this. And so in a vocoder, you have a bank of filters that are typically band pass or something, and they're isolating little sections of the spectrum, and there's circuitry that extracts amplitude for each of those bands, and then that turns into your, you've analyzed the spectrum of your input signal. And then those circuits that extract the amplitude information from the bands, that control signal then is applied to the tops of these sliders, so that it is automatically kind of turning up and down the gains of each of the 10 filters. So the result is, if I speak into this, in theory, let's get it somewhere around here. There it is. The spectral shift in the middle is tuned to kind of a classic vocoder setting. And if I give it a nice pulse wave and a little bit of noise, you can get some vocal sounds. You can change the carrier. The carrier oscillator can be modulated volt per octave, so you can sequence things. And as I said, you can replace the carrier oscillator with a variety of sound sources. So that's a very basic vocoder sound, and there's other things you can do that are quite cool. So I showed you the audio rate modulation. So if I'm going to tune that up real quick. Hang on. take on vocoding because that voltage control of the spectrum is really cool. The other thing you can do is you can shift the spectrum up and down with this knob. So I can make it sound like my formants are going up, or I can make it sound like my formants are going down. And there's this other switch that says hiss and buzz, and this replaces the carrier input for these top two bands with noise, so it sounds like.
Ah, right.
So for making speech sounds, it makes it sound like you're saying S or T or these sort of things.
Right.
Yeah.
Okay, so Steve, what do we have on the CV side?
Yeah. On the CV side, so as I said, there's a program input for if you have Eurorack level signals, carrier input again for replacing the carrier on this side of the knob of carrier mix. There's an output that is the instrument output at Eurorack levels, which is like 10 volts peak to peak or so. Control for the VCA, there's an output master VCA, so that if you're using this as a synth voice, you can send gates and trigger an envelope and have it sound much like a synth. You got 1 volt per octave VCO's input, control input, and an output from the selection of your VCO. Pulse width modulation, CV input, a noise output, so you can use the white noise as a sound source and something else, or a modulation source. You got mod rate input and a mod output. That's a triangle wave LFO, and this mod rate input is trimmed to 1 volt per octave, so it doesn't go past about like 500 hertz-ish, but you could use it as a little bass oscillator if you'd like to. Trigger input will fire the envelope generator. There's other ways to fire the envelope generator. You got that right there. It's a very simple one. It's kind of percussive. So you can actually use this thing to make, as I said, with the resonant filters and the white noise and all these things, you can use this to make some interesting percussion sounds as well. There's a CV input for the spectral shift, so you can sequence that control, things like that. Oh yes, a gate input for this hold feature. I didn't show you the hold feature.
Oh, okay.
I'll do that real quick. So hold is it's sort of like sample and hold for your and the spectral amplitude information. So I can say ah, and turn that on. And it says ah. You can have fun with the ah. And then, yeah, so that's so you can capture that. So you can actually sequence the capturing of these little phonemes that sounds.
Okay.
Yeah. Oops, turn that off. And then the other cool thing about this, I think that is fun, is that you have an output from the program input with this gain level. So you can take a mic, plug it in, amplify the heck out of it, and then that is then going to be at Eurorack level, so you can use that signal to modulate stuff, or as a sound source in your Eurorack system. And then you also have a possibility of extracting a trigger signal from whatever comes into the program input. That can be used for firing envelopes or doing stuff, as it were, with trigger signals.
Right.
So,
so I guess the big question then is, when will we know more or less if this is actually going to be available outside of the festival?
oh, I don't know the answer to that. I mean, there's
Possibility.
This was designed for the folks who do the engineering
That's
workshop.
very cool.
And it was an interesting collaboration. There's another engineer, Gene Stopp, came up with kind of this idea of using the types of filters that we're using for the synthesis side. And we were like, how is it even possible? Because it's all analog. Is it going to be possible to fit it into this space? And it is. It turns out that it is. And it was a really fun project, turning it from an idea, kind of a kooky idea, into something that makes some really, really interesting sounds.
Okay.
Yeah, so.
Excellent. All right. Well, we'll keep our fingers crossed that this might be out there in the world soon.
Be cool.
All right,
All right
Steve.
with that.
Thanks so much.
Okay.
Appreciate it.
Okay, thanks.